Hello, my friends. Welcome to Origins. My name is Don Chapman. It's so good to have you with us today. Thanks for joining us. You know, Origins is a forum where we take the evidence of science and we use it to validate the truth of creation. We have a great guest with us today. Dr. Nelson is with us. Dr. Paul Nelson, he's a PhD from the University of Chicago. He's a professor at Biola University and also a fellow at the Discovery Institute. We're so thankful that God's given us guys like you, and we are grateful that you would come be with us today.
Listen, it's wonderful to be here. I really enjoy my job.
Now, we're talking about the miracle of development. And so we're going to talk about Darwinian evolution. What's the core process of Darwinian evolution?
The central theory that was really, I guess you could say, discovered by Darwin is called natural selection. And it has three fundamental requirements. Variation, you've got to have differences in some trait. Those differences have to make a difference to the number of offspring you leave, and call that selection. And the last requirement is heredity. You need to be able to pass that trait on to your offspring. Now, you can think about this like, I don't know, three legs of a stool.
Sure.
Each of these requirements is necessary. By themselves, they're not sufficient. But if you get them all together, natural selection will operate. And it's a real process. The question is, can it do the work of evolution? Now, there's one point that I really need to stress, and that is, for evolution to operate, you've got to be able to leave offspring. If you can't, you're an evolutionary dead end. We'll come back to that because when you come to the puzzle of where animals came from, it turns out to matter.
It does matter. So if you can't reproduce, you can't do evolution.
You can't have evolution. Evolution will not occur. Actually, it might be easier if I went up to the board.
I think it would be great if you go to the
explain.
board and show us what you got for us up there.
All right, suppose we want to explain an evolutionary transition where a species A will turn into species B through time. Now, of course, real organisms are more interesting than colored squares, or colored shapes, I should say. But this will give you the idea that we want to change the form, the overall form of the organism. Now, if A and B are animals, they will be built, as you and I were built, by a process of development, where in almost every case, you start with a single cell, the fertilized egg, then there's a long developmental process that ensues, leading eventually to the adult. Now, it's in the adult stage that you have reproductive capability. That matters for natural selection because one of the necessary requirements of our three-legged stool is being able to produce offspring, to reproduce. So, that's how A is built. And if we want to change A, the shape, the form, into something like B, we're going to have to change the construction process. You know, if you ran an automobile factory and you wanted to change from a particular kind of engine, let's say a V6, to a rotary engine, or change the axle, some fundamental part of the architecture, you'd have to change the construction process right from the start. So that's what we're dealing with here, to have this process of macroevolution occur, if it will. Now, here's an important point to keep in mind when we come to our example later. This can't happen. There's no possibility of being temporarily dead during the evolutionary process.
Okay.
Not even for 5 minutes or 30 seconds. So if the evolutionary hypothesis that you've proposed requires you to go through a temporarily lifeless stage, on those grounds alone, you can rule it out. All right. That's not going to happen. We'll keep that in mind. Now, here's the challenge for natural selection. As I said, it's a real process. We actually have lots of examples of natural selection in action, such as in things like antibiotic resistance. But can that process of selection do something like this? Here's a very simple hypothetical animal. Has only 5 cells. They have to be arrayed in this pattern for reproductive capability. If you start here with a single cell, somehow you've got to put all these instructions in place to get you over to this distant target. Here's another metaphor that I think helps to make the point. We're taping this show in Pittsburgh. You have lots of these, some of them quite elegant and beautiful.
Lots of bridges.
Lots of bridges. Let's say this is a 1,000-foot chasm. You definitely don't want to fall down in there. Now, you can think about development like a kind of magic bridge. Right right at home in an Indiana Jones movie. Let's say you're standing over there and you want to get to this side and you start walking across. As long as you keep walking, the bridge will be there beneath your feet. The minute you stop to look over the edge or turn around, the bridge disappears. Development is very much like that. When a cell-fertilized egg begins to divide, heading towards the adult, it's got to keep going to get all the way over here where reproductive capability is going to commence. So, remember our 3 requirements and leaving offspring? These are critical for natural selection to operate. Let's take a real-life example. This a female monarch.
A beautiful example at that.
Beautiful example. The male has little dark patches here on either side of the abdomen where the male stores pheromones. These are chemicals that attract females. Those are his cologne patches, if you will. The amazing thing about butterflies, well, one of the amazing things, is that when you look at them close up, the complexity and precision of their design is just breathtaking.
When you hold a living butterfly in your hand for the first time, maybe you've netted it or you've picked it off a flower or something, here's this incredibly beautiful organism, intricately shaped with its feet and antennae and all these things moving at once.
Every one of these 20,000 species have different color patterns, and every one of them has different shaped wings. The diversity is just so magnificent. If I was the greatest artist in the world, there was no way I could come up with all of these patterns. I mean, it would be just absolutely impossible.
If you open the work of a lepidopterist, someone who studies butterflies, somewhere in that writing, you're going to find the language of astonishment. The fact that it goes through a caterpillar stage and then becomes this mysterious chrysalis, out of which this flying creature emerges, has captured the imagination of people since antiquity.
Throughout history, butterflies have touched the human mind and soul on levels both scientific and philosophical. 3,500 years ago, Egyptian artists studied their anatomies and then rendered them as icons of beauty and perfection of form. In Aztec and Mayan folklore, the insects symbolized life and death.
Monarchs appear to pass through a stage in their development where they look for all the world like they're not alive. It's a puzzle for evolution because, well, here's another way of thinking about it. This is Houdini with 3 of his assistants, and he's being lowered by his feet into a water box. Now, he's not going to go in unless he has a plan for getting out. He just won't let himself do that.
At least not more than once.
No. He probably has a backup plan to
Sure
the backup
he does,
plan. Yeah. All right. Well, the parallel to butterfly development is really pretty strong. If you look at the monarch life cycle, there's a stage in which you're neither a caterpillar nor a butterfly. You're on your way between these 2 ways of making a living. The question is, how did all of this evolve if natural selection was the causal process? So let's look at a little bit of the details. Here is a monarch egg, carefully deposited by the mother on the underside of a milkweed plant. When you look at it more closely, it's a beautifully symmetrical little structure. There's actually an air hole up at the top there. Now, after the caterpillar goes through various molts, at the end of the caterpillar phase of its life, it forms this characteristic J shape, attaches itself to the underside of a twig or some structure like that, and then sheds its skin for the final time to form the chrysalis. And this is the real mystery stage. Before we get there, though, let me show you something interesting about the attachment point here. The chrysalis is attached by a structure called a cremaster. This is a scanning electron micrograph of that device, showing you how it embeds in a silk pad that's spun by the caterpillar. Let's zoom in for a better view, because there's an interesting detail here that you really shouldn't miss. There are these specialized hooks on the cremaster that attach or snag silk threads. Now, from an engineering perspective, ask yourself this question: why have these hooks if you don't have the silk pad? There'd be nothing for them to attach to. But why have the silk pad if you don't have the hooks? So you've got two components, both of which are necessary for function, neither of which by itself would do the job. For that, I think you need an engineer, not a blind process like natural selection. Anyway, what's going on in this mystery stage? Well, a bunch of things. The first thing that's happening is the caterpillar tissues are being destroyed. Those cells digest themselves and cells around them, breaking down the components really into a soup, a molecular soup. So most of the tissue of the caterpillar is being digested away as the first part of this process. But then the second stage is really even more interesting. Beginning with small populations of cells that were present even in the caterpillar, the adult structures of the butterfly are being constructed, like the legs, the gut, the mouth parts, and so on.
So it de-assembles itself into really a soup.
Yes.
And then it reassembles itself into body parts of the butterfly. Is that what I'm hearing?
It's truly amazing. In fact, I never would have the heart to do this, but if you take a scalpel and cut the chrysalis head to tail like that and pour the contents out on a cover slip, it looks like kind of shapeless jello.
Yeah.
There's really nothing there that your eye can see that corresponds to structure.
Now, can you give us an example out of technology of something like that to help the viewers understand?
Sure, watch this video clip.
A butterfly chrysalis connects two fundamentally different ways of living. It is both a bridge and a workshop where one type of organism is transformed into another. The magnitude of this transformation has been compared to a Model T Ford that suddenly encases itself within a garage. Inside, most of the car breaks down into fragments of metal, rubber, and glass. These pieces then reorganize themselves into components more complex than any that previously existed in the Model T. After several days, the garage door bursts open and a radically different mode of transportation lifts off into the sky.
Now, Dr. Nelson, as I watch that video, I chuckle to myself when it says it deassembles itself. Okay, so something can blow up and deassemble. Then it says it reassembles itself into something. So that what goes in as a Model T comes out as a helicopter. We sit there and say, now that's ridiculous and that's impossible.
There
but
it
in
is.
fact, that's what happens, isn't it?
It's happening.
Yeah.
It's happening.
And this is even more miraculous than that.
Oh, by orders of magnitude.
Yes.
So let's pick up the story at the end when, if you will, the helicopter comes out. The chrysalis begins to darken after about a week goes by, and you can begin to make out the colors and the patterns of the adult butterfly. It emerges, pumps up its wings. As they dry, they become flight-worthy or flight-capable structures, puts its proboscis together. Let's go back to Houdini to show you just what a puzzle this is for evolution. So I told you Houdini, and I think everyone would agree, is not going to go in the box without a plan to get out. Well, let's compare Houdini to the butterfly. Going in, death is the consequence unless you've got a plan to get out and probably a backup plan as well. In an exactly parallel fashion, no caterpillar will dissolve itself, form a chrysalis, and say, well, I think I'll stop here. This is enough for today. No. There must be the engineering, the plan to get out of that stage into the viable butterfly adult. So the problem for natural selection is because the process has no foresight, it's incapable of building these long-range developmental plans where you end up neither caterpillar nor adult butterfly, but a soup in the middle.
There's no transitional things there at all.
No.
It's broken.
Remember this diagram. You can't evolve through a temporarily lifeless stage. Now, even though you can tell that the chrysalis is still alive because there's a measurable heartbeat there, that's not a viable organism in terms of making a living.
Are you saying that virtually every other part of the butterfly breaks down except the heart?
Almost everything else is dissolved away. There's a few structures that continue through, but pretty much the rest of it is dissolved.
That's amazing. A huge problem for evolution, and we want to talk about the implications of it. And we have just been looking at the butterfly, which seems to cause some very unique problems for natural selection.
Yeah.
What are some of the answers that the evolutionary community would give?
Well, let me tell you an interesting story about a paper that was published 3 years ago.
Okay.
In 2009, in a leading journal, Proceedings of the National Academy of Sciences. The author was a guy named Donald Williamson. He's a zoologist at the University of Liverpool in England. And Williamson started his paper by saying, the prevailing Darwinian scenario just doesn't work. Caterpillars and butterflies are just too different as creatures, the way they make their living and so forth, their anatomy, for there to have been any kind of step-by-step natural selection scenario to explain the evolution. So his argument was, we need to try something else. We need to try a radically different hypothesis, and here's what he came up with. Before I tell you that, though, let me say a little bit about what happened after this paper was published.
All right.
This journal used to have a special track for members of the National Academy. If you were a member, you could fast-track either one of your papers or from a colleague, fast-track that paper into print, speed up the review process. Williamson was friends with a woman named Lynn Margulis, a leading biologist at the University of Massachusetts, who was a National Academy member. She fast-tracked this paper. It created such a controversy that after it was published, the National Academy eliminated that pathway. It doesn't exist anymore.
Not only did they take it away from her, they took the whole pathway away.
For everybody.
Yeah.
From everybody. But here's what he came up with. He said, let's start with something that looks kind of like a caterpillar. Now, this is not a caterpillar, even though it sort of looks like it. It's called an onychophoran, or a velvet worm.
Okay.
It's got the stubby little legs,
Yeah,
the tubular body. Kind of looks like a caterpillar. We don't have these in North America. You have to go elsewhere in the world to see them. He said, you'll start with that, and then you'll use probably some kind of arthropod species, like a grasshopper, that doesn't go through metamorphosis. When a grasshopper is born, newly hatched out of the egg, it looks very much like an adult. So they grow, add a few details, their wings get longer, their sexual organs develop. But a baby grasshopper looks like a miniature adult grasshopper. Doesn't go through this dramatic metamorphosis that we've seen. All right, so velvet worm, grasshopper-like, arthropod, they meet at a singles bar, and it all works out.
So he said they crossbreed.
They hybridize.
Yeah.
Now, that's just never, ever going to happen. I mean, that would be like you hybridizing with a clam. The genetic incompatibilities, God forbid, right?
Yeah. Thank you.
The genetic incompatibilities are
By the way, I think he already has.
Yes, he took care of that already, yeah. Now, I very much doubt that this ever happened or would work. What's interesting is Williamson felt the problem was so severe and that evolutionary theory had really reached a point of crisis that he needed to try an idea like this to get out of the rut that the theory was in.
This is what you would call in football a Hail Mary.
Yes.
Isn't it?
Yes.
Uh-huh.
It's a Hail Mary.
It just doesn't have much chance of working, but the problem's so desperate you have to go for it.
You got to try for it.
Yeah.
Right. Now, I need to be careful and say that this is not the mainstream evolutionary view.
This wasn't widely accepted.
No, it was not. In fact, as I said, the paper itself caused such a problem that they changed the way they were going to publish
But
papers.
the fact that he felt compelled to come up with a theory like this tells us a lot, doesn't it?
Right. Tells us that the problem is severe. But
Yeah.
what's interesting is this problem has been known for a long time, the problem of evolving development. When I was much more slender and had all my hair, I remember as a student reading the work of Rupert Riedel, who understood this problem in great detail, and he called it the paradox of teleological evolution. He compared embryos to diagrams of organisms. They're not yet functional. Actually, the metaphor he used was an architectural one. Imagine a building surrounded by scaffolding, and you're at the building site, there are piles of lumber, plumbing equipment, you name it. The building is kind of there, you can kind of make out the outline and the scaffolding, but you can't live there. Can't use it for an office. It's not habitable. It's not a functional structure because it's on its way to becoming a building. And Riedel said when we look at the embryos of animals, what we see is something on its way towards function, but it doesn't yet possess full function. And it's a real puzzle for natural selection how those embryonic pathways evolved, given that the functional endpoint is in the distance. So his view was, again, we need to try something new, staying within, of course, the framework of naturalism.
And does he come up with something, or he just gives the cry in '78 that we have to try something?
Right, we have to try something. The problem is still unsolved.
And so is it widely accepted that we don't have an answer?
It is widely accepted that we don't have an answer. The problem, again, for evolution is all the possible answers, the possible range of solutions fall within this naturalistic framework. But if the data you're looking at indicate intelligent design, that framework is intrinsically insufficient. You need to break out of it, try something new, and I think what is needed is intelligent design. I should point out, by the way, that the way animals today solve the problem of being an embryo is having mom and dad. Mom and dad put the instructions in place to get you across that magic bridge.
The butterfly also says to me, though, that God puts a high value on beauty.
Yes, he does. And my own estimation is that he couldn't have made it more obvious. In fact, for the ancient Greeks, their word for soul was also their word for butterfly, psyche. Yeah. They saw spiritual significance in these creatures. Yeah. And from my own Christian perspective, the metamorphosis of a butterfly may even be a tiny, beautiful model of our personal resurrection. Yeah. That we're caterpillars now, and we're going to be something much more magnificent after what appears to be the end of our existence. Yeah. In that chrysalis, there's not a functional organism. It's alive, but it can't make a living staying there. It's heading towards something much more beautiful.